Okay, so we're going to be getting started with our intro to the egg bungee jump. And so here's kind of a little setup here. And before we get started, I want you to go ahead and draw an LOL chart to represent the energy transfer here. I'm not going to be going over it in the video. You need to have it in your notes to be prepared for our discussion on Monday. So stop, think about what's happening if you take an egg, attach it to a bungee, and drop it and make it bounce. Okay? It should be, and the bungee's going to kind of catch it before it hits the ground. Okay? And so think about what kind of energy you're starting with and what kind of energy you're ending with, and be sure to write an equation there. Okay? So a couple pieces of information I'm going to share with you. The height that we're going to be dropping it from will be the back of the pool bleachers again, which is about 4.8 meters. Might be slightly higher. I'm going to let you know for sure on Monday or Tuesday how we'll be attaching it and dropping it. Okay, and the materials we'll be using, you're going to get an egg, you're going to get a bag to put it in, or a baggie, let's just say bag. There you go, a bag. You're going to get a spring, and you're actually going to use 2 springs, and I'll explain about that in a minute. Okay, and we're going to use some string. Okay, and so what's going to happen is this. We're going to use these pieces of equipment to set up an apparatus so that when we drop the egg, it's going to fall down as close to the ground as possible without hitting it. And really our goal is to come within about 5 centimeters. Okay, and it is very doable. Okay, last year we did it with rubber bands, which did not work very well. This year we're using springs, and they're going to work great. Okay, I've already tested it once. So in order to do so, though, think about this energy that's going to be going into the spring. What kind of energy is that? Well, it's elastic potential energy. Okay. Now, of these things, we can actually calculate how much the egg is going to cause that spring to stretch. Okay, but in order to do so, we need to know what K is. All right, well, I'm going to remind you as we think back to last semester that if we are to construct a graph that relates the amount of force applied to a spring with how much it stretches, and through this, by plotting that relationship for a spring, the slope of it is K. Okay, and it came from this equation right here. So if you're able to graph this equation, do the best fit line, and get this, then you'll be able to get your K value, which we can then use later in our energy equation. Okay, and this is useful for us because we can find how much that spring is going to stretch. Okay, so when we go out and we drop this thing, here's what it's going to look like. Okay, so we're going to have, like if it was just hanging down, you would have some amount of like string. Okay, then you're going to have spring, and you're actually going to have the 2 springs attached together, and I'll explain more about that in a minute. Okay, so there's 1 spring, 2 springs, and then at the very bottom you're going to have a little baggie that's hanging with the egg in it. Okay, so we have all of these components here. We have some length of string, which we'll call L. We have the spring right here, which is the length of the spring plus X for however much it stretches. And then we have the length or the height of this baggie, which we'll call H. Now if we add all of, or we'll just call it B for baggie, how about, since we have H for the total height. So all of these things have to add up to the total height that it's being dropped, which in this case is going to be about 4.8 meters. Okay, so of these things, we can measure the length of these springs, we can measure the height of this bag. We have to calculate how much those springs are going to stretch using K value, using elastic potential energy. Okay, we need this X to get this. Okay, so we need to take data to get K, because once we take K, we can do our calculation to figure out how much this stretch is going to be right here. And once we know what that stretch is, our job basically is to find out, well, how much additional string do I need to add so that when I drop it, it comes close to hitting the ground without hitting. Okay, and if we think about thermal energy here, if we do everything to match the exact height it's going to fall, it's not actually going to fall quite that far, because some of the energy is going to go to thermal energy and be lost instead of going into the spring. Okay, so let's kind of summarize what I just said. You have this device that you're making made up of string, 2 springs attached together, and the egg in a bag. Okay, where our goal is to figure out how much of this string we need to measure out for the top, so that when we drop this, it's going to come close to the ground without hitting. Now we can measure the height of this bag again. We can measure the length of the springs again. We have to calculate how much those springs are going to stretch, and using all these measurements and knowing how far it's going to fall, we have to calculate calculate how much string to use. Then we'll go ahead and measure out the string and construct our device from there. Okay, so the last thing I want to mention is why we're using 2 springs. Okay, so when we take our data here, we're limited by the size of our room as well as the number of springs that we have. So we can measure the relationship between force and stretch by putting different amounts of weight on here and measuring what that stretch is. Okay, we'll construct a table. You're going to do this on a Google sheet, and then do it in Desmos to your best fit line like we did before. Okay, and once we have this done, our best fit line, we get our K value. Okay, we can then calculate the amount of stretch for when the egg is dropped. Okay, but it turns out that even though we have to cut these springs in half in order to, or we have to use these short springs to take data in the room, it's actually much more interesting if we attach 2 springs together, because we get a little bit more of a bounce there. Okay, so it'll be more exciting to watch. It'll be a more exciting bungee jump, and at the end of the day, more exciting is what we're looking for here. Okay, so what happens though is you have 2 springs that are going to have similar but slightly different K values. Okay, and so they're also going to have 2 different lengths. So for the combined length of the springs, you would add those 2 lengths together, and to find the K value of the 2 springs, before we do that, what do you think is going to happen? If you add 2 springs together, do you think their K value should be bigger or smaller? Should they be stretchier or less stretchy? I mean, let's rephrase that. Should the K value be bigger or smaller? Should they be harder to stretch with 2 springs or easier to stretch? Okay. And the answer to that question is, the more springs you have attached together, the easier to stretch it will be, which means that K is going to go down. And here's how you find our new K value. We're going to find the average of K1 and K2, and we're going to take that average and then we're going to divide it by 2 to get our new K value, because it's going to basically cut the original K value in half. Okay, so when you do this, you're going to basically partner with another group and share springs with them. Please don't share your data, so you each have your own calculations, and maybe the other group will be unsuccessful while you're successful. We'll go ahead and see when we do our egg bungee jump. But at the end of the day, on Thursday when we do our drop, you're going to be sharing a spring with another group, okay? Because each group is going to need 2 springs, and we only basically have enough springs for each group to have 1.